So we are doing a little bit of review today. So algebra review. We want to be able to solve quadratic equations mostly. I'm actually going to I don't know, maybe just do, well, let's just do one of these. We'll just do one of these algebra equations. I think you guys are pretty good solving algebra. So let's look at number 4. It is the, well, quote unquote, hardest of the questions. So if we wanted to solve number 4 here, what would you want to do first? Times by 2, absolutely. Right now, 2 is dividing everything on the right. That's why there's this big division sign. And so to get rid of that, which cleans it up really easily, we can times by 2. But this is the tricky part. You have to times everything by 2 on the left-hand side as well. So the 2's cancel out on the right, but on the left-hand side, we have to do what with this 2?
Times it by 2.
14, yeah, we have to distribute the 2. We have to multiply each term by 2, not just the 2x. So we get 4x minus 14 equals, and then over here on the right-hand side, what else do we need to do? Yeah, there's a -1 right here that we are also going to need to distribute. You can imagine there's a little invisible 1 there. And we want to distribute that -1 inside the parentheses just to clean that up as well. So 8x minus 47, negative times 3x is negative 3x. Negative times negative 14 becomes positive 14. Then we can go ahead and clean up the right-hand side a little bit. Just combine our like terms. So I have 4x minus 14 equals, and then 8x minus 3x is 5x's. And I have a negative 47 and a positive 14. Was that negative 33? Okay. I'm going to go ahead and move my letters to the left then. So I'm going to subtract 5x because that's how I teach algebra. I make my algebra students move letters to the left. Because it's an alliteration. Do you know what alliteration is?
Yeah.
Peter Piper picked a peck of pickled peppers. Yeah? Repeated consonant sound. So letters to the left is a good one. It sticks in your brain just a little bit. Anyway, 4x's minus 5x's is -1x minus 14 equals negative 33. And then I can go ahead and add 14 and add 14. So I have a negative x equals negative 15, 16, 17, 18? Negative 18? 19. 19 will do better. Which means x equals positive 19. Yep. Okay, so times and by 2, good strategy there when you have a big old division problem. Good way to clean that up. So really I want to focus on quadratics. So for set 2, we want to make sure that you know how to multiply binomials or FOIL. FOIL is the phrase F-O-I-L. What does that stand for? First. See, I didn't teach you guys algebra. Outside. Inside and last is what FOIL stands for. First, outsides, insides, and last. But really, what we're doing here when we multiply binomials is we're just distributing. That's all we're doing. And so what we have here, just so you know the vocabulary, binomial. Bi means what? 2. Nomial means term. So 2 terms. So we have 2 terms being multiplied to another binomial. So this is a binomial times a binomial. And down here, these are called binomial squares. Binomial squares because they're being squared by that power of 2. All right. So that is the vocabulary. So we're going to go ahead and multiply. So for number 5, all we're doing really is distributing the x, and that's what the first and the outside means. It's first times first, and then the outer pair, so that's the first and the outside just by distributing the x. What is x times x? And then x times negative 1? Negative x. And then we're also going to distribute the 8. And again, that 8 gets distributed to the other bubble, and that gives us the inside pair, the two inner terms, and then last is last times last, so the last parts of the bubbles. So we have 8 times x is positive 8x, and then 8 times negative 1 is negative 8. So from there, we just have to combine like terms. Negative 1x plus 8x is positive 7x. I can do these in my head. I don't have to write this middle step here. If you can do that, that's fantastic. I want you to be able to get to the end quickly. Okay. I used to give my algebra students so many of these, like we'd start with 50. They'd come in and have their warm-up with 50.
There's people waiting up there.
Okay.
Because they're going to chemistry games. Oh, they're going to chemistry.
Okay. All right. I would like you to do the next 6, 7, and 8. These ones are a little bit more challenging.
6, 7?
6, 7, and 8. So go ahead and distribute. 3x squared. 3x times 6 is 18x. And negative 5x and negative 30, and combining like terms, we would have 3x squared plus 13x minus 30. Go ahead and do 7 and 8.
Jane, why would I have a will of 15?
Go ahead and do 7 and 8.
Here's the show. That one.
8 has a mistake, Bella. What's x times x?
X squared.
X squared.
Thank you.
All right. So on number 7, you should have 10x squared minus 39x plus 14. I did that in my head just in case you're curious. And number 8, you should have 4x squared minus 1. What happens on this one?
They cancel out.
Yeah, the middle term cancels out. This is called the sum and difference pattern. It happens every time you have the same numbers, but the signs are opposite. That middle term is always going to cancel out. So that's the sum and difference pattern. Down here, binomial squares, there is an expansion pattern you can use, but I think the best strategy is always just to write it out 2 times because that's what a power means. It says repeat everything in parentheses 2 times. And so really that 2 just tells you to repeat. It's repeated multiplication. And from there, we can do the same thing. X squared plus 9x. The inside is 9x. And last times last is 81. X squared plus 18x plus, 81. And the same thing on number 10. I would simply write it out 2 times because that's what a power means. It says repeated multiplication that many times. First times first would be 16x squared. The outside is 12x. The inside is another 12x. And last times last is 9. So we get 16x squared plus 24x plus 9. Any questions on those? Hopefully that's easy review math, yeah? So the important part about learning how to do foiling is that we want to be able to go in reverse really quickly. And that's the most important part. If you're given 4x squared minus 1, I want you to know how to go backwards and unfoil, if you will. So it's called factoring. I call it double bubbling because I like the visual that it gives. So we want to be able to double bubble. And that's what we're going to do here. And so on number 11, factor really means just double bubble. You should write that down because that is a good phrase because it gives you a structure to latch onto. Factor means double bubble, and we want to unfoil, and it's a really easy pattern that comes from foiling, essentially. When we foil, we know first times first has to be the first thing in that trinomial. So first times first has to give us x squared. What times what gives us x squared? X times x. And then last times last has to be the last thing. The last thing is positive 21. What times what gives us positive 21? 7 times 3, but also negative 7 times negative 3 gives us positive 21 as well. It's important that we consider that as well. Also, the only other option is 21 times 1 and negative 21 times negative 1. Those all give us positive 21. And we want this first one was said, the positive 7 and the positive 3. Now, the question is, how do you know if you did it right? 7 and 3 make the 10. So the best way I want you to know how to do this is that you check the outside and inside product. That's all you have to double check. So I call it checking the grin. You see the smiley face there? It's a little smile. Okay. Check the grin. That's the outer and the inner. The outer product here, 3 times x is 3x, and 7 times x is 7x. And when you combine those, you get the 10x. This is called an easy trinomial. It's called an easy trinomial because it's easy to see that 7 and 3 make 10. The problem is most of them aren't easy. They're hard trinomials, in which case the outer and inner product, checking the grin, is necessary, okay, because you won't see it readily, all right? Let's try a couple more here. So we're going to double bubble. And first times first has to be x squared. What times what is x squared? X and x. And then last times last has to be negative 36. What times what is negative 36? Negative 6 and positive 6.
Negative 18 times negative 2.
Negative 18 times positive 2 or negative 2 times positive 18. You got negative 9 times 4 or vice versa, negative 4 times 9. I like to make a good list here. Which one is the winner? Negative 2 and positive 18 is our winner for this one. Negative 2 and positive 18. And again, you can check the outer and inner, but then this is an easy trinomial. X times 18 is 18x. Negative 2 times x is negative 2x. And when we combine those, that gets us our middle term there. All right, let's double bubble. Number 13, x times x is x squared. Last times last has to be negative 28. What times what is negative 28?
7 and 4.
7 and 4 would give me positive 28. So negative 7 and positive 4, or negative 4 and positive 7.
Negative 2 times 14.
That's true.
14 times 6.
That's true. And 28 and negative 1, vice versa. So which one is our winner?
Negative 4.
Negative 4 and positive 7. It does not matter how you put the negative 4 and the positive 7 in your bubble, as long as the 4 is negative. So it could have been in the other bubble. Will you try number 14? And 15 and 16, frankly, but 14 for sure. So you want to get a positive 12. What times what gets you positive 12? And negative 4 and negative 3. Positive 4 and positive 3. All right, which one's going to give you a positive 7? All right, super. All right, and number 14, x times x gives us x squared. And we're trying to make a positive 12. That would be 3 and 4, or negative 3 and negative 4. We have 2 and 6 also works. But 3 and 4 is the winner. So positive 3 and positive 4 are the factors that we're looking for. Here, we only have 2 terms, and it's a subtraction sign. This is called difference of squares. And it's important to recognize it's called difference of squares because difference means subtraction. And then we have in front and at the back are perfect squares. X times x is x squared, and 64 is 8 times 8. So those are both perfect squares. If you ever see difference of squares, the difference of 2 things that are perfect squares, then it factors into that sum and difference pattern. What times what is x squared?
Only x.
X times x. And then what times what is negative 64?
Negative 8 times.
Negative 8 times positive 8. Negative 8 times positive 8. It factors the exact same way, but it is a special pattern. Here again, we have difference of perfect squares because 9x squared is 3x times 3x. That's a perfect square, and 1 is 1 times 1. So how is it going to factor? 3x times 3x is 9x squared, and what times what is negative 1?
Negative 1 times positive.
Yep, negative 1 and positive 1. So those are special patterns that are good to recognize, but they factor exactly the same way. My method of factoring works all the time. When you have a hard trinomial, it takes a little extra time. But it works. Okay, so we also want to be able to solve quadratic equations. Solving quadratic equations, you'll notice this first one, we always set them equal to 0, factor, and solve. That is the process for any higher order equation. By higher order, I mean anything with a power. X squared, x cubed, x to the 4th. It is the exact same process. We always push everything to one side and factor and solve. So here, we have our equation set equal to 0, and so we are going to factor. X times x is x squared. What times what is positive 20? 10 times 2, negative 2 times 10, what else? Negative 5, oh, it's positive 20. I'm sorry, that's supposed to be negative 2 times negative 10. Negative 5 and negative 4, or positive 5 and positive 4. Okay, which one do we want? Negative 5 and negative 4. Once you have your bubbles, then you get to set each bubble equal to 0. So each bubble gets set equal to 0. X minus 4 can be 0, or x minus 5 could equal 0. That's going to allow us to isolate the x. How do I get the x by itself?
Myself in the problem.
Yeah, you just add 4 to both sides. So you get x equals 4, so there's one answer. And here we would add 5 to both sides, so we get x equals 5. My pen is out. Shit. All right. What do we need to do on number 21? Yeah, we got to make it equal to 0. So I actually need to subtract the x from both sides. I also need to subtract the 24 to move it to the left-hand side so that nothing is left on the right. I have an x squared, negative 9x, and negative 1x is negative 10x, and a minus 24 is set equal to 0. So we got to set everything equal to 0. Then we can factor. What times what is x squared?
X.
X times x. And then last times last has to be negative 24. What times what is negative 24? Negative 6 times positive 4. What else?
Positive 4 times
Negative 4 times positive 6. That's what I don't have it now. Yeah. Negative 12 and positive 2, or negative 2 and positive 12. 24 and 1. 8 and 3. That's a good one. Negative 8 and positive 3. All right, which one do we want? Yep, negative 12 and positive 2 gives us that negative 10 we want. Lots of listing here. I think it's the best way, mostly because it helps us remember our multiplication facts, ladies and gentlemen. Writing lists isn't bad. It helps our memories, okay? And then we set each bubble equal to 0. So I have x minus 12 equals 0, which means what? Yeah, I got to add the 12. We get x equals positive 12. And here, x plus 2 equals 0. I've got to subtract the 2 to move it over, so I get x equals negative 2.
Could it be 6 and 4 though?
No, the reason it can't be is because we're making negative 24. So negative 6 and positive 4 give us negative 24 when we multiply. But when we add those, we're going to just get negative 2. And then we have negative 4 and positive 6. That would only give us positive 2. All right, same thing on number 23. I need to move everything over. I'm just going to draw little arrows because, you know, I'm lazy. X squared, I'm going to add 4x. That gives me 14x's. I'm going to add 40. And now we're set equal to 0. To move things over, you got to do the opposite. And then we can double bubble. X times x is x squared. What times what is positive 40?
4 and 10.
Yeah, 4 times 10 or negative 4 times negative 10. I think we found our winner. Positive 4 and positive 10. From there, we set each bubble equal to 0. That's the 0 product property. It says if we want the whole thing to equal 0, logically, if one thing is 0, then 0 times anything is 0. All right, so that's how we set each of those equal to 0. We use it a lot in math. And then I'm going to isolate the x. We get negative 4, and move over that 10. We get a negative 10. Do you guys have questions for me? Okay. All right, you guys have a little delta math to work on.